Good morning, this is P. Shivashankar Rajamani, Associate Professor, Department of ECE, KSR College of Engineering. So today I will be discussing about a series RLC circuit. So in this, you already know that since it is a series RLC circuit, it consists of a resistance, an inductance and capacitance which are connected in series. We have a problem. Analyze the performance of a series RLC circuit having resistor 100 ohms, an inductor of 50 millihenry and capacitance of 20 microfarad, which is connected with 230 voltage 50 Hz AC supply. Determine the total impedance, current flowing through the circuit, phase angle and draw the phasor diagram. If the value of the inductor is made 506.7 millihenry, what would be the phasor diagram after changing the value? So this is the question. So we already know that R is equal to 100 ohms and L is equal to 50 millihenry and C is equal to 20 microfarad, which is connected in series. All the three elements are connected in series. So the 230 voltage supply 50 Hz. So from this, the given data R is equal to 100 ohms and L is 50 millihenry and C is capacitance is 20 microfarad. So first we need to find the inductive reactance. So we already know that inductive reactance is equal to 2 pi F into L. So F is already given us 50 Hz and L is given us 50 millihenry. So XL is equal to 2.34 into 50 into 50 into 10 power minus 3. So if you do the calculation, XL is equal to 15.71 ohms. Then we need to find the capacitive reactance. So XC is equal to 1 divided by 2 pi F into C. So we already know that F is equal to 50 Hz and C is equal to 20 microfarad. So if we substitute this value, it's 1 divided by 2 into 3.14 into 50 into 20 into 10 power minus 6. So if you do that, XC is equal to, it's 159.15 ohms. So which is being given in the right side. XL is equal to 15.71 and XC is equal to 159.15 ohms. So we need to find the total impedance. So for finding the total impedance, Z, which is equal to square root of R square plus XL minus XC the whole square. So we already know that XL is the reactance, inductive reactance minus capacitive reactance. So since the value of capacitance value is very high, so we just convert this formula. So Z is equal to square root of R square plus XC minus XL the whole square. So we substitute this value. So R is equal to 100. So it's Z is equal to square root of 100 square plus 159.15 minus 15.71 the whole square. So if you simplify that, so you will be getting Z is equal to 174.9. So this was the first question, total impedance. So Z is equal to 174.92 ohms. Then the second question asked is find the current. So we already know that current is equal to voltage divided by total impedance. So voltage is 230 voltage, impedance is 174.92. So the current is 1.315 amps. So this was the second question asked. And the third question is find the phase angle theta. So we already know that formula tan theta is equal to XC minus XL divided by R. So we want theta. So theta is equal to tan inverse of 159.15 minus 15.71 divided by 100. So we could able to see that theta is equal to minus 55.12 angle. So since the theta is minus 55, so it is leaves in the fourth quadrant as per the circuit. So it shows that the circuit is capacity in nature because of the negative angle. So we need to find the phasor diagram. So we already know that voltage of resistance, voltage across the resistance and the current are in phase with each other. So this orange color and green color, they are in phase with each other. So XL is equal to, it's in the 90 degree. So voltage, here it is, voltage is leading in the inductor circuit, whereas voltage is lagging in the capacitor circuit. So since the theta angle is minus 55.12, so which is the total impedance XC minus XL. So the angle between the current and the voltage is minus 55.12. So here the capacitive reactance is dominating. So the question asks us, after changing the value from L to 50 millihenry to 506.7 millihenry, so we will see what happens to the XL or what happens to the phasor diagram. So inductive reactance, so we already know that formula XL is equal to, it's 2 pi F into L, so it's 2 into 3.14 into 506.7 into 10 power minus 3, so the value is 159.15 ohms. The capacitive reactance, which has already been solved, so X is equal to, it's 1 divided by 2 pi F into C. So it's 2 into 3.14 into 50 into 20 10 power minus 6. So the value is 159.15 ohms. Here we could be able to see that the capacitive reactance 159.15 ohms and the inductive reactance is also 159.15 ohms. So if you want to find the total impedance, that is equal to square root of R square plus XL minus XC the whole square. So if you put the values of R, so R we already know that's 100 square plus XC value is 159.15. Likewise XC value is also 159.15. So 159.15 minus 159.15 the whole square. So since both the components are subtracted, so the value is 0. So Z is equal to square root of 100 square. So Z value is 100. So Z, which is equal to the resistor value. Before the Z was 174.92, but now the impedance, total impedance has reduced from 174.92 to 100. Here the next question is current, find the current. So current I is equal to, it's V divided by Z. So here Z is equal to R, so it's 230 divided by 100, which is equal to 2.3 amps. Before the current was 1.315 amps. So after changing the value of your inductance, the current is increased to 2.3 amps. So that is the arrow showing that impedance before it was 174.92, Now it has changed to 100 ohms. So which was the initial value of your impedance. So after inductance is changed to 506.7 millihenry. So before here the phase angle is theta. So tan theta is equal to XC minus XL divided by R. So XL and XC are same. So it's 159.15 minus 159.15 divided by resistance R, which is equal to 100. So tan inverse of 0 divided by 100, so just theta is equal to 0. So before it was minus 55.52, which was purely a capacitive network, but now it has theta is equal to 0, which is in phase with the current, or we could able to see that the voltage and the impedance or the phase angle are 0. So the angle 0 indicates the circuit is purely resistive in nature. So we could able to see that VR is the voltage drop across resistance and VL is the voltage drop across inductance, which is 90 degree, where your voltage is leading, whereas the voltage for capacitance is lagging by 90 degree. So the overall combination, which is in phase with your current. So XL is equal to XC. So the inductive reactance is equal to capacitive reactance. This is a similar case which is called as resonance. The angle 0 indicates the circuit is purely resistive in nature. After analyzing the circuits, it was found that XL is equal to XC, the imaginary part is equal to 0. The circuit behaves as resonance circuit having maximum current of 2.3 amps. Before it was 1.3, now the current has increased to 2.3 amps. So at low frequency, the capacitance will be dominating, and at high frequency, inductance will be dominating. Since the current becomes maximum at resonant frequency, the series RLC circuit, resonant circuit is also called as acceptor circuit. So this is the analysis that we have made. So before it was 50 millihenry, the theta was minus 55 angle, whereas when your inductance values increase to 506.7 millihenry, the theta value is 0, which is in phase with your current. So which is a purely a resistive network.